12.12. You had fun with those proofs, right? So let's do more, but add more stuff. We're talking about sum and difference of angles identities. So we're adding more identities, but we're still going to be using them in the same way to try to manipulate trig functions to make them easier to solve. Okay, so we've got a couple of new identities to go over. We've got the sum of angles. Remember, sum is when they're added together. So we've got sine of a plus b, so that's two angles added together inside of the function. We can actually split that up into sine of a times cosine of b plus cosine of a times sine of b. Now, at some point in your mathematical career, you may prove this, but for now, put it on a note card or use that trig sheet. But either way, so same thing for cosine of a plus b, cosine of a times cosine b minus sine of a sine of b. So again, there's kind of a pattern here, but man, it's really hard for me to remember everything, but it's okay. So then we got tangent of a plus b. This one's good fun. Tangent of a plus tangent of b, 1 minus tangent of a times tangent of b. And then difference of angles, so we can subtract, same thing, a minus b, this is inside the function, inside the trig function. Then we've got sine of a times cosine of b minus cosine of a times sine of b. And then you've got a similar one right here for cosine of a minus b. And then tangent, it looks pretty similar except our signs have changed. Again, we're going to be using this sheet. I'm not going to have you memorize them. You're going to be able to use your trig sheet on the test, but you need to be able to look at this and problem solve with those things. So it's really important to be familiar with it, even if you don't have them memorized. All right, directions say find the exact value of each expression, use the sum and difference identities to break the value apart into unit circle angles. Now, we of course skipped the unit circle because whatever, we decided to skip it. But what they mean by that is you need to, the hardest part about this is breaking this angle up into two angles that we know how to do. So remember, we learned special triangles, 30, 60, 90, and the 45, 45 degree triangles. But remember, if let's say you have a angle like this, and let's say this is 45 degrees, but the actual angle here is whatever, 180 minus 45. Whoops, 180 minus 45. So this angle would be like 135 degrees. So when we find, let's say, sine of 135, we would just use this reference triangle right here to figure that out. And it would be we would use this as a 45 degree triangle, in which case sine of 135 would be 1 over square root of 2 or square root of 2 over 2. So that's what they're referring to, is trying to find those angles that we know how to find in order to break this thing up using the sum angles and figure it out. So let's look at 165. So number one, if I'm thinking about my 30, 60, 90 triangle, none of those have a 5 in them. So I know for a fact that 45 degrees is going to play into this somehow. So I kind of already talked about this 135. So I'm going to start with that. So let's see if we can break this up into 135 plus something. So let's see here, 165 minus 135 is going to be 30. Okay, so this is equal to 135 plus 30 degrees. So now we can change this into sine of 135 plus 30. So in my opinion, that's the hardest part. We got it. We're done with the hardest part for this problem. So now we use the sum of angles, and I even went and got my formula sheet because I didn't want to keep switching back and forth. So let's see here, sum of angles identity, sine of A plus B equals sine of A, we're going to call my A 135, times cosine of B, in this case that's 30, plus cosine of A, which is 135, times sine of B, which is 30. So we're doing 135, which I kind of have a picture up there, and we're doing 30. So I'm just going to make my little triangle here. We're going to call this 30 degrees. So that's 1, 2, square root of 3. So these are the pictures that I'm going to use to solve these. So what is sine of 135? Sine of 135 is opposite over hypotenuse. So that's going to be square root of 2 over 2. What is the cosine of 30? Cosine of 30 is adjacent over hypotenuse. So that's going to be square root of 3 over 2. And then plus, what is cosine of 135? Adjacent over hypotenuse. Okay, yeah, so that would still be square root of 2 over 2. And then sine of 30 is going to be 1/2 times 1/2. Okay, so we just do some math. Hey, look, it's all, well, whatever. So we got square root of 5 over 4 plus square root of 2 over 4. So our answer... Okay, so I made a mistake here, and it's a mistake that we're all going to make a dozen times, so I didn't correct it because I wanted everybody to see it. So when I took the cosine of 135, we are over in this quadrant. So, and we're doing this one adjacent over hypotenuse. This is a negative value because it's on the negative side of the x. So I should have made this one right here negative. So I didn't do that. That was a mistake. So I'm going to keep that a different color just to remind everybody to not forget about those negative signs like I did. Okay, so now we'll get the right answer. So we'll have square root of 5 minus square root of 2 over 4, and this is the answer we're looking for. All right, looking at number 3, I'll admit, I've been staring at it for a little bit. I've been trying to figure out how to divide this angle up using radians. I give up. I can't do it. I'm not as familiar with radians as I am with degrees, so forget about it. I'm just going to turn it to degrees and see where we're at. So I use my calculator, 180 divided by 12. We've got 15 degrees. So we're dealing with tangent of 15 degrees. So we also learned, so that means that we are doing the difference of angles identity. So we're going to have to subtract to get there. It's a 5, so we're going to have to subtract 45 at some point. So let's see here. I wonder what 15 plus 45 is. So 60. So we could do tangent of 60 minus 45. So that would equal 15. And these are both things that I know that I can do trig with. So that's the hardest part, I feel like, of the problem. The rest of it is now we got to plug and chug. So I'm looking at my difference of angles identity. Tangent of A minus B equals tangent of A, tangent of 60 minus tangent of 45 divided by 1 plus tangent of A, which is 60, times tangent of B, which is 45. Okay, so tangent of 60 is just going to be a triangle like this. And that's my 60. That's my 30. So it's going to be 1, 2, square root of 3. And we are dealing with this angle right there. And then we're going to do tangent of 45. That's just this guy right here. 1, 1, square root of 2. So I'm checking negative signs because I made that mistake already. Both of these are in quadrant 1, which means that this is positive, that's positive, that's positive. Everything is positive. Great. I love that. That means I don't have to worry about that. So now we're just going to go through and we're going to evaluate the stuff that we know. So this is my 60 degrees. This is my 45. So tangent of 60 is opposite over adjacent, square root of 3 over 1, minus tangent of 45, opposite over adjacent, 1. Okay, we got to move some stuff around. Whatever, we'll keep going. Okay, and that's all over 1 plus tangent of 60, and I'm going to move this so you can see this better here in just a second. Tangent of 60 is 1 over 2, and then times tangent of 45, which is 1 over 1. Okay, so let's move this over. Oh my gosh. So we can see it. Okay, so then we're just doing our fraction game. Let's simplify our fraction. This is going to be square root of 3 minus 1 over 1. So I don't really have to write that. Divided by, this is just 1/2. 1 plus 1/2 is going to be 3 over half. Oh, that's 3 over 2. Should be 3 over 2, 3 halves. So then we're going to multiply by the reciprocal up to the top. And then we're going to have 3 on the bottom. And then 2 square root of 3 minus 2. So I was looking at the solution manual. This is not the right answer. So I kind of wanted to go through like how I was troubleshooting. So first I checked to make sure that I wrote down the equation right. I did. So then I checked, okay, did I do tangent of 60 right? So that one is right. Tangent of 45, that one is right. 1. So then tangent of 60, I said was 1/2. So that's where my mistake was. So let's start there and let's keep going. So that troubleshooting process I think is important to see because you're going to make a mistake in one of these and you're going to need to be able to figure out where you made the mistake. So that's where I'm at. Anyway, so tangent of 60 is square root of 3 over 1, and then times tangent of 45, which is 1. So now we have square root of 3 over 1, we're right here. Square root of 3 over 1 is just square root of 3. So we got square root of 3 minus 1 over 1 plus square root of 3. Okay, so we can't have the square root of 3 in the bottom. So we are going to have to multiply by the reciprocal. 1 minus square root of 3. And we'll do that just right below that. So I'm going to start on the bottom. So 1 times 1 is 1. And then plus square root of 3 minus square root of 3. They cancel out. Minus 3 over square root of 3 times 1. Square root of 3. Square root of 3 times negative square root of 3 minus 3. Negative 1 times 1. Yeah, minus 1. Negative 1 times square root of 3. Negative square root of 3 is plus square root of 3. So now these guys cancel out. We've got 1 minus 3 on the bottom, so we got negative 2 on the bottom. And then we've got 2 square roots of 3. We're combining our square roots of 3 minus 4. And then we can simplify that to our 2's cancel out. Let's see, that would be a 2 left over. And then we'll just change all of the signs. And then we're going to have... so if we change all of our signs, we're going to have square root of 3